Hello students, today we will be discussed another topic of green chemistry, that is healthier fats and oils can be prepared by using green chemistry by this way. So first of all we have to know which one is fats and oil. So fats and oils are the triglyceride of some fatty acid. Fatty acid is the long chain or is the number of carbon is C18. It is unsaturated C18, this is saturated C18, C16 palmitic acid, linoleic acid, etc. So, and this kind of triglyceride of such kind of, that is R1, R2 or R3, this may be different or may be same, or two may be same and others may be defined, are called triglyceride. So this long chain fatty acids, is R1, R2 and R3 are this such kind. This first one is called the stearic acid. Again it is C18 species, and second one is called the oleic acid. Now the triglyceride means what? That is triester of glycerol. So if we changes the structure, that means if we replace the hydrogen and hydrogen, this is nothing but glycerol. So the triglyceride is the triester of this glycerol. This alcohol part is glycerol and acid parts are this long chain fatty acid. So fats and oils, so that fats and oils are similar the chemical structure, but they have, oil has the physical states are different, because oil are room temperature. At room temperature it will be liquid, but fats are not liquid at room temperature. That means the species which are liquid at room temperature are commonly called oils, and the species which are not liquid or the solid is called the fats, that means at room temperature. So for having the saturated fatty acids in their structure has high melting point. So if it is saturated, if this chain is saturated, then it has the higher melting point, and if this one is unsaturated, that means such kind of R1 is there, it has lower melting point, structure of high melting, and those containing unsaturated state. So now what's the problem there? If this unsaturated is present in any one of these one, can be rancid very easily. That's why oils can be rancid very easily, as these are contains some double bonds in their fatty acid chain. But generally fats are solid at room temperature and they have more stability. As they will be saturated there, then there is a higher melting point will be there. So how this rancidity can occur due to the presence of this such kind of double bond, that will be now discussed here. That is, as the double bond is present in the R1, R2 or R3, then their allylic position, that means this position of R. So this one is the allylic position of that R, that is this position or this position. These are actually the allylic position of that R. In presence of some free radical can be reacted. So in presence of free radical, that can be changes to the other. So how they can be changes to other, that can be shown by the following reaction scheme. So what is the actual mechanism to rancid the corresponding oil which contains this one? So what will be the structure of this one? This will be CH2 of one of the glycerol part, that is CH2 and then it will be CH right here, that is CO another R1, and that will be another, that is CH2 and it will be OR1. Here all the R1s are same here, because the another R1 is this one, that is CR1 is this way. So by this way how we can represent this? It's maybe R1 or maybe R2 or other. So in presence of the free radicals, what should be happening there? Free radicals means reactive oxygen species. This is called the ROS, reactive oxygen species, such example for this one. If this radical is present in the system or the atmosphere, then it can react the initiation, the reaction, and finally reacts with oxygen from air to from the hydroperoxide. So what will be the first step? In the first step, the water molecule will be eliminated from this allylic position and it may gives the corresponding. So this is the continuous chain is from here, and this is the part that is the allylic part. So one of the allylic part is shown here. So it will be now generates a radical species which can react with the species present in the oxygen. So the rest portion are same here. This rest portion, there is this portion and this portion here. There is the allylic position of the present double bond. That's why this one is rancid. That mechanism can be given here. So in presence of this hydrogen oxygen, aerial oxygen, it can convert such kind of species, that is C double bond, this and this will be oxygen radical, and that will be this one, and which is in intermediate state, and next it can be convert to the hydroperoxide. So it can take a hydrogen and got the corresponding hydroperoxide. There's this one, this, and the oxygen, hydrogen, and this will be this one. So this actually other chains are present there. So this hydroperoxide plus, that means the two molecules of this, that will be chain initiation reaction, and so hydrogen will be taken up from another, that is it produces another, is this one, that free radical will be generated by here. So this is another taken from saturated, so that it gives the corresponding hydroperoxide, and this one is again given this. So this is actually the free radical reaction can be carried out, and finally this hydroperoxide converted to this hydroperoxide can be converted to the aldehyde, ketones, or epoxide or carboxylic acid. So it can be converted to the aldehyde, ketones, carboxylic acid, epoxides acid. Epoxides acid. So due to the formation of such kind of reaction, the oil, that is which contains the double bond, will be rancid during the time. So how can we check this rancidity? Now we can check this rancidity by catalytic hydrogenation of oil. Now what is the catalytic hydrogenation of oil? So oil is nothing but containing the double bond, that is its melting point is lower, its melting point will be lower, hence is liquid at room temperature. So when oil will be hydrogenated, so we can take this one as the structure 1, 2, 3, 4, 5, 6, 7, 8. The same chain will be continued here. That means the same chain will be continued. Same chain, that means this chain is repeated here. So this one will be called the trioline, that is trioline. That means its melting point is only minus, melting point equals to minus 4 degrees centigrade. So clearly this is the oilic acid. This one is oilic acid, 9, 10, and 18. This is oilic acid. So this is the triester of oilic acid, and it will be liquid at room temperature. Now if we carried out the catalytic hydrogenation of this one, then this trioline, which at melting point minus 4 degrees centigrade, will convert it to the corresponding saturated one. So all these ones are saturated. So this one's melting point will be now increases to the 72 degrees centigrade, and its name will be taken as it will be stearic acid. So it will be named as, that is C80 and saturated, so it will be named as stearic acid, and its name is stearin, SteArin. So this will be generated there. So by this way, by catalytic hydrogenation, we got this from what? That is triolene, which is a oil. This triolene was the oil as it was room temperature. At room temperature it was liquid, that should be oil, and now it will be converted to the fat as it has higher. It will be converted to the saturated fat, not only fat, it will be saturated. Why saturated? No double bond is saturated. So it is more stable as there is no double bond is present in this ring. So there will be no rancidity, and it will be more stable for few days or long time. So the increase of double bond in the fatty acid chain, then it will got to the oil. Now we can hydrogenate it partial hydrogenation. If we use some margarine, which is a semi-solid fat, can be prepared from vegetable oil by partial hydrogenation. It is the full hydrogenation. Now if we carried out the partial hydrogenation, then what should happen there? So if we carried out the partial hydrogenation of the oils, which again contains the unsaturated double bonds. Now if we carried out the partial hydrogenation, we got a semi-solid, including that it gives the more stable trans double bond also. So we got the trans double bond in the fatty acid chain. So as the you know that for cis and for the trans, this one will be trans, other will be present there. So such kind of bonds are there. So it will be cis and this will be trans there. So clearly, as the trans is more stable, so it will be crystal packing will be higher, and glycerides with greater number of trans double bond exhibit higher melting point. So there will be such kind of triglyceride, that is O, C double bond O, it will be CH2, CHO, again C double bond, and it will be there here, and here will be CH2O and C double bond O, CH2O, C double bond O, and such kind. If the number of trans double bond is increases, trans and trans double bond is present here, here it may be cis there. So as the number of trans double bond is increases, then its melting point is also higher. It goes to the higher melting point and better packing possibilities. Why this contains higher? Because the better packing possibilities in its crystal lattice, as it will be more symmetrical. You know that the trans are trans having generally higher melting point than the cis one. So the natural occurring oils containing the cis is more, which is very good for us, and so natural oil, it contains only 0.5% trans acid, trans double bond, trans double bond in natural oil. But when you consider to the partial hydrogenation, it gives you the partial hydrogenation of this one, partial hydrogenation, so that we can increase its stability and avoid the rancidity, partial hydrogenation. So that's how double bond should be there. Then it will give the trans, amount of the trans will goes to the 30 to 40%. So the trans double bond will be increases here. So this will be synthetic, as there will be the partial hydrogenation is carried out there. So it will be called the synthetic oil. But the natural oil is very good for us, not the synthetic oil. So what is the problem with the trans fatty acid? So we may call this one the trans fatty acid. So trans fatty acid is a triglyceride which is responsible for increasing the melting point in the hydrogenated oil. So we may call this as a hydrogenated oil. It's maybe saturated as partial hydrogenation, so some double bonds will be there. The drawbacks of this generated trans double bond is that it increases the LDL, that is low density lipoprotein. Okay, LDL. If you carried out the LDL lipoprotein, low density lipoprotein, if you carried out the lipid profile test, then LDL is bad for us, but HDL, that is high density lipoprotein, is very good for us. Now this LDL will be increased in presence of this trans fatty acid in the cholesterol present in our body. That's why it increases the chances of coronary heart disease, which is actually called blockage, some deposition of LDL and other in the coronary. That's called the coronary heart disease will be there. So it is good to decrease. So what is the aim? So it good to decrease this number of trans fatty acid in this bond. So in search of such kind of, so up to this we'll explain why trans fatty acid is bad and what is the rancidity and what is the difference between oil and fat, which one is good for us, and naturally occurring oil contents we can do. Now for searching and overcoming for these drawbacks, that is trans fatty acids, you have to avoid the trans fatty acid, then we can carry out the other reactions. So the scientists and companies are fine to other process so that the unhealthy trans fatty acid can be avoided from the natural one. That means oil can convert the fat again, but without forming so much trans double bond, that is trans double bond in the fat. So this process is named as by interesterification. This process is called the interesterification. Okay, so this one is the process by which we can exchange the function among the different triglycerides. So there are two triglycerides, A plus B. Now if we carried out this such process, that is interesterification, carried out this, then there will be, we got a mixture of fatty acid, mixture of fat. We got the mixture of fat or fatty acid. So how we got the mixture of fat? Because there will be no hydrogenation is carried out, only the interesterification was carried out. By what method? I will come later. By what method we can do this? So there will be, if A and B and another 6, total 8 are possible, including A and B. So if the A and B has the melting point, let it has -4 degrees centigrade and it has 72 degrees centigrade. Clearly this one is saturated and this one is unsaturated. This one is triolene and this one is triacetate. So now we got the mixture of this 8 here. So we got the melting point of this resulting triglyceride in between these two. Okay. So by this way we can carry out that the number of double bond are same, that means A, and it cannot isomerize to the corresponding trans one. So now if we take an example of A and B, so what are the 8 can be possible here. So I take these two, that is R1 O CH2 CH O C double bond O R2 and CH2 O C double bond O, and here will be all these are R1, and plus if I take another one that contains the CH2O C double bond O and this will be R2. Here will be CHO, CHO, C double bond OR2, and this one is CH2O, C double bond OR2. So these are actually two triglyceride A and B taken here, and these processes are carried out by this one interesterification. If we carried out here interesterification, then including A and B, there will be another 6 are possible, that is 1, 2, 3, 4, 5, 6. So I can write them as this one. So first of all 2, that will be R1, R1, and this will goes to the R2. So now this product here, okay? So I want to draw the product here. So this one is first one, that one will be now A converted to the 1, and if this one is R2, R2, and this one will be R1. So clearly these two are exchanged to each other from A and B, and let this one is 4 here. So this one is 2, that means A plus B plus 1 plus 4. Okay. Now if you carried out this as R2, that is first one is R2 and this one is now R1. Okay. So these two are exchanged to each other, so it will be R2. And if this one will be 2 and this one will be now 5. So another will be 2 plus 5. Okay. So another 2 is here. And if these two are R1 and this is R2, and so clearly this will be R1 and these are the two R2. So this will be 3 and this will be 6. So another will be 3 plus 6. So total 8 are possible here. So by this way, the mixture of, so this is nothing but mixture. This is mixture of fats or oils. We will tell this fats or oils, mixture of fats and oils. So if we take the example, that is triolene, which has melting point minus 4 degrees centigrade, that is A minus 4 degrees centigrade, and we give the triostyrene, which is melting point minus 72 degrees centigrade. So only 72 degrees centigrade. So now we got, after interesterification, we got A, B, 1, 2, 3, 4, 5, 6. So clearly it has the boiling point in between these two, that is minus 4 degrees centigrade and plus 72 degrees centigrade. So by this way, we can increase the melting point of the oils and without increasing the trans fatty acid in the triglycerides. Okay. So by this way means that is interesterification. By using interesterification, we can achieve our goal. Now, what are the chemical processes for this interesterification? Okay. So there are two processes are present here. First one is, so how we can carry out this process? First one is chemical. That means number 1, chemical interesterification. We will treat this as C, write this as CIE. And in number 2, which is called the enzyme, ENZYME, enzyme IE. So this will be E, I and E. So clearly, we have to this one will be the green method, or you can told it as a cost effective or other effective. So first we have to discuss details about the number 1, that is CIE, chemical interesterification. How can we carry it out? What are the drawbacks? So now this chemical interesterification is accomplished by treating the glycerides, that is A and B, with the sodium methoxide. So A plus B is treated with NaOH. Okay, so this will be treated with NaOH. So using this NaOH as a catalyst, we can convert a large number of problems with respect to. So what we can convert into the others. Okay, so this will be mixture. This is a mixture of the fats and oils we got there. Now, what are the problems for using the NaOH? So it has very much problem for using NaOMe, the CIE, that is chemical interesterification. So first problem for using CIE is the NaOMe is to be removed. After reaction you have to be remove the NaOMe. So it is a strong base. So we need a treatment of acid to the produced fat or oil mixture by the acid, and then it should be washing with water. So a wastewater shows a high biological demand, BOD. You know all of them, that is BOD, biological oxygen demand is increased, and wastewater treatment is a costly process. So the industry is not accepted very well. Now the starting glyceride always contaminates, that is A and B, that is the starting glyceride always contaminates some free acids, because few of not reacted with glycerol, so they will be attained as acid. So that acid will be reacted with the NaOM, so it will give its salts there. Yes or no? So you have to be purified or free from this. So that is another good, the loss of the product, at least 5 to 6% oils are lost for this process, for this washing and treatment of this one. And this one is the second one, that one was the A. And the last problem for this is further purification is necessary for the decolor. Color impurities will be present there. As you know that some reactions, others reaction may happen, so this will give the colored product. So colored obtained can be colored compound have to be treated so that we can got the decolorized oil. So again it is another point, loss of desired glyceride and cost is also increases there. So this is all about our CIE. Now I move to the number 2, that is EIE, that is enzyme interesterification. So the process are same, but this will be now changes here. So we have to be used enzyme as the catalyst here. Enzyme will be act as the catalyst here. So what kind of enzyme are used here? That is lipase or phospholipase types are enzymes are used here. So by this process we can change oil into the fat by this way. So first is lipase catalyzed synthesis, cocoa butter equivalent from the palm oil. So palm oil can convert it to the cocoa butter, and improved lipase enzyme is called lipase TL. TL stands for Thermominus languicea, was developed by American company Novozymes. So these are the history how this one changes there. The technology was commercialized by Archer Daniel Midland company, that is ADM, for the production of margarine without trans fatty acids using enzyme. Which enzyme? That is lipase by lipozyme TL enzyme. The technology will be developed by the ADM company. For this development, Novozymes and ADM company jointly received the Presidential Green Chemistry Challenge Award in 2005. Nowadays, the later development of this one is the immobilized enzyme linking with silica. So what is this one? Immobilized enzyme linking with silica. This immobilized enzyme can readily separate it from oil by filtration and reuse the catalyst, decreases the cost of the preparation. ADM has changed the condition for reaction to enhance the life of the immobilized enzyme catalyst. So by this way, this EIE nowadays used for the convert the oil into the mixture of fats or oil, so that we can avoid the maximum number of trans fats in the partial hydrogenation or other process. So recently enzyme have been used for the production of amphiphilic esters from carbohydrate, mannitol, sorbitol using vinyl esters and other. So now the last part, what are the merits of EIA over now the merits over CIE. So what will be the merits? So there will be three merits will be there. First one is no strong base is used in EIE. So hence no problem for use the large amount of water or other acids. So the wastewater treatment will be very much lowered in the EIE over CIE. And no byproduct like soap or salt is produced, because in the free acids that cannot be reacted with the enzyme, or it does not give the corresponding salts or other, which is found in case of CIE. So the loss of triglyceride is very much less. That means yield will be higher in case of EIE over the CIE. And last one, no decolorization is necessary for the EIE process, because there is no color is generated from here. So by this way we can use our healthier fats and oil by the green chemistry. Okay, thank you.